So far, we have seen the usage of define to define functions. But most of our examples were contrived and not close to real-world use cases. At work, the functions we define might need to handle a variable number of arguments, or they might need to destructure a large map passed in as an argument. In this chapter, we learn various aspects of defining functions in Clojure. The examples in this chapter are coded in the first project .fndefs namespace. Can you figure out the disk path of this namespace? Multi-arity functions let you accept different number or type of variables. They work by defining different execution paths for different arguments, and are generally used to provide default arguments. Multi-arity functions are conceptually similar to function overloading. Anonymous functions are functions that have no home, i.e. are not namespace qualified. They exist only at the point of definition and are useful for a variety of applications, like defining callbacks or simple predicates. There are two ways to define inline functions, using the fn macro or using the hash parentheses shorthand. Fn and defn have similar signatures, except the function name is not present while using fn. With the shorthand, we can completely skip the argument vectors and access the arguments using the %n sign, where n is the index of the argument which we want to access, starting with 1. If you need to capture only one argument, you can skip the index and simply use the % sign. Anonymous functions are helpful while working with sequence operations like map and reduce. We will see them in action soon. Functions defined with defn or fn can follow an alternate signature to specify inline documentation. Variable additive or variadic functions lets you capture any number of arguments as a list. We have seen this function already in the first project.core namespace. Variadic functions use ampersand to signify the variable number of arguments. The rest variables is available in the function scope as a list. If we call f with 5 arguments, f1, 2, 3, 4, 5, then arg1's value will be 1 and rest will be a list of 4 elements 2, 3, 4, 5. We have so far called functions by passing the arguments manually. For example, f defined above is called by typing f1, 2, 3, 4, 5. But what if we wanted to call f for a list of n integers? What if these arguments were stored in a variable? The apply function lets you unpack sequences and use them as function arguments. Apply f list is same as calling f with the values of list unpacked and sent in as arguments. In UI programming frameworks like React, it is common to pass down props to child components. It is also fairly common to pass configuration maps as function arguments. Sometimes you might need only a small part of the argument. Destructuring helps you precisely pull out the required pieces. Let us suppose that a function takes a 3-element vector as an argument. This vector is fetched directly from a database and holds the name, age, and height of a user. If we wanted to get name, age, and height with what we know so far, we could simply write something like this. The first, second, and last function pull out the first, second, and last element of the vector. This doesn't spark joy. With sequence destructuring, the same code can be rewritten as so. The order of elements is important while destructuring sequences. If you don't care about an argument, say age, you can use an underscore in place of the variable name. You can just let it be age2, but if a variable is not used in a function, the linter might complain. You can also use the underscore prefix like underscore age instead of just an underscore. The underscore prefix can be used with normal functions too, i.e. where destructuring is not being used. You can also use destructuring with let bindings. If you want to destructure and do not pull out all elements of the sequence, the tailing elements are ignored. Let us assume that we have the following worldview of a user: name, John Doe, age 29, and so on. And we pass the user to a function that prints their name and age. With all that we know so far, the definition of this function might look something similar to, this seems reasonable, but can get out of control as the function assumes more responsibility. Also, what happens if you want to use the age or name more than once? You can call the keyword as function at multiple places, but a let binding makes more sense. The example above is more realistic. With map destructuring, the function can be rewritten as so. There is still some repetition. The variable age and the map he age appear twice. This can be helpful if you want to call map key 8 something else in your function scope. But if you want the variable names to be same as map keys, you can further rewrite the same as follows. Notice the use of keys in destructuring. We can go one step further by getting rid of let and destructuring the arguments directly in the function arguments vector. In the real world, your map representing your knowledge about a user might not be perfect. It might be missing some information. For example, our user John doesn't have any information about time zone. Destructuring lets you assume defaults if the required information is missing in the map. We can use the OR form for destructuring to assume defaults. All destructuring constructs work at any level of nesting. If you have a 2x2 matrix and want to destructure all elements, you can just nest the syntax. We added an extra line break in the example for better readability. As you become used to the syntax, you will be able to read and write a destructuring like this in a single line. We can also destructure a nested map in a similar way. The nested map destructuring is a combination of destructuring techniques used in print user 4 and print user 5 function. It is okay if you don't get this in the first go. As you work with functions, you will develop an eye to read complex destructures. We have referred to many functions such as defin and when, which are in fact macros. Macros rewrite your code at build time. For example, defin macro converts your function definition into a variable definition using def. We will not study about macros in detail, but we should make clear that some symbols that we refer to as functions might be macros. Functional composition lets us apply multiple functions to an argument in series. The comp function takes multiple functions and returns a new function which is an effective composition of inputs. In this example, the composed function inc_square first squares the input and then increments it by 1. Comp PQR arguments is same as P of Q of R of arguments. Partials or partial functions reduce the argument count of a function by setting defaults. The add function takes 2 arguments, but the add5 partial sets the default argument on add as 5. In this chapter, we learned about various types of function definitions. We then moved to argument destructuring and made a distinction between function and macros. Destructuring makes code concise, but at the same time hard to read for beginners. With knowledge of various destructuring methods, you'd be able to read publicly available code with more ease and over time write more efficient and concise Clojure.